So we are on, you guys. So Common Core, G for geometry, CO for congruence, and it's number 10 on the list, and it stands for proving theorems about triangles. Right, there we go. So in example 1, we want to say why the two triangles are congruent. Okay, remember we need three things. The three things that we have so far is side, 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 right? Oh, side, 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 and our other is our side angle. Side. Over here I said that you can't use AAA. Angle, angle, angle does not work. And the reason it doesn't work is because you can have a big triangle, and you have a little triangle, or a big triangle, a little triangle that have the exact same shape, right? All the angles are equal, but the sizes are different. So those wouldn't be congruent. Does that make sense? Angle, angle, angle wouldn't work. And of course, we also know the side, side angle doesn't work. It does not work. Okay. And you can't forget this one because it really could be angle, side, side, and that's not a very nice word. So these are the ones that we could. Whoops. Sorry. These are the ones that don't work. Side, side, angle. Okay. We won't use those. So take a look at the first example. I've got a side to a side, I've got a side to a side, so it looks to me that I could probably say that triangle ABD is congruent to triangle BDC, but I'm missing a third thing, and hopefully you guys can see the third thing. What's the third thing? We need three things. What's the third thing? I mean, I've got a side to a side, that's one. I've got a side to a side, that's two. What's my other thing? Don't they share this side?
Yes.
So if they share the side, they both have a side that's equal, right? So that could be my third thing. So in our proof, we have to say that. We've got to at least say that BD is congruent to BD. We have to say that because they both then have the third side, where we have 10 goes to 10, 8 goes to 8. Now all of a sudden this side, even though we don't know the length of it, we know they have to be, it's the same side for both triangles. Okay, so then once we have that, we can say that triangle ABD is congruent. Triangle ABD is congruent to triangle. Let's see, we got to be careful. Got to make sure that we put our corresponding angles together. So A really goes to C, so I'll say C. B goes to itself, right? Angle B to angle B. And of course, angle D would go into angle D. Okay, so triangle ABD would be congruent to triangle CBD. So we want to make sure that the corresponding angles line up. Okay, that makes sense? Okay, by SSS. Thumbs up. Does that seem pretty easy? Sideways? Okay. All right, let's look at number 2. We need three things, right? Number 2, I know the 12 goes to the 12. 13 goes to 13. So that's a side to a side, a side to a side. But I need a third thing. You need three things. What's my third pair?
Angle.
It's the angle. Yeah, it's the angle. In fact, what angle do you see?
Z.
Guys, so we got to be careful when we say Z. I totally agree with you. Katie's totally right. We got to be careful. We can't call it Z because the problem if we call it exactly Z is this angle Z? Is it this angle Z? So I agree with you. We're going to say that angle YZX is going to be congruent to, gotta be careful, QZW. So match it up because Y does go to Q, right? And X goes to W. So when I match it up, I've got Y goes to Q, Z to Z, and X goes to W, okay? So then that's by what reason? What's my reason? Why is that? Yes, almost, but why are the angles congruent? You're one step ahead of me. Why are the angles congruent?
Because they're right next. They're vertical.
There you go.
Angles.
VAT. So by vertical angle theorem, right? The vertical angles? Good.
We can't see it.
Oh, sorry. Okay, vertical angle theorem, right? So now, the next thing is to say the triangles are congruent because you have the three things. Once you have a side to a side, a side to a side, an angle to an angle, once you have the three things, you can say the triangles are congruent. So I'll go straight to triangle YCX is congruent. Keep them matched up, triangle QZW, because Y does go to Q, right? Z goes to Z, and X goes to W. Okay, now what's the reason? Why are these two triangles congruent? By SAS. So when you say the triangles are congruent, you have to say either one of those. Side, 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 or side, angle, side. I'll say it again. When you make the statement, the triangles are congruent, you have to use one of these two. Those are the reasons, okay? All right? Number 3. So, show the triangles are congruent if x equals to 3. Well, let's just plug it in. Let's plug in 3 here. Let's plug in 3 here and plug in 3 here and see if they are congruent. So if I plug in 3, 3 times 3 minus 5 is 9 minus 5, which is 4. This side's 4, right? 3 minus 1, which is 2. Okay, and then if it's 3, it's 3. So let's see if it matches up. So, all right, the 3 goes to 3, right? That matches up. The 4 goes to the 4, that matches up. And what other kind of cool colors do I have? The 2 goes to the 2, right? So definitely, yes, by what reason? SSS, right? So we can say the triangle, let's see, VWU, VWU is congruent to triangle. Let's see. V's got to go to what side? Probably Y. Nope. X. Thank you. X. And then W would go to Z, right? And then U would go to Y. By side, side, side. SSS. Nice. Nice job. Okay, not too bad, is it? How am I doing? Thumbs up? Okay. It's okay. Okay, example 4. Let's take a look at it. So let's plug in the 7. So I plug in the 7 here. I'd have 2 times 7 plus 1. 14 plus 1 is 15. Okay, good. Because 15 corresponds to that 15, right? Okay, let's plug in the 7 here. Let's see, it's 7 squared minus 4 times 7 plus 3. I might cheat and use my calculator, right? Why not, right? My calculator do the work. So I'm going to go...
24. Oh,
you're way ahead of me. Minus 4 times 7 plus 3. And it is 24, okay? Oh, ignore my phone. So it's 24. And that's good because then it shows me that this side is going to be congruent to that side, okay? And then finally, if we plug in the 7 in here, I believe it's 126. Pretty sure it is. If I go 12 times my 7 plus 42, yeah, 126. 126. So my angles correspond too, okay? So I'd say yes, right? Definitely yes by, but what are the 3 things? Why are these 2 triangles congruent?
Side, angle, side.
Everybody agree? Side, angle, side, side, angle, side. So let's see if we can write this down. So I'm going to say triangle. Let's go, oh, I don't know, how about DFE? Congruent to triangle. Let's see, D would go to H, I think. It's turned around, right? D goes to H. F would go to J. And then E would have to go to G by side, angle, side. Sometimes the hardest part is getting the right angles lined up because, you know, we turn them around on purpose, okay? So far, so good? All right, turn the page. Oh, approve. Oh, my goodness gracious, approve. Well, let's go back to what we do with proofs. For me, first thing I do is I look at the given. I always look at the given, and I look for keywords, okay? So for me in here, a keyword is this parallel, okay? The parallel is a keyword for me because I know with parallel lines, I can go back a chapter, corresponding angles, alternate interior angles, right? When I think parallel lines, I'm thinking, you know, corresponding angles, alternate interior angles, okay? And they've got some congruency, so I'm going to mark my figure. And then finally, what I'm going to do is prove, well, let me mark it. It helps me too. EGF. So on this triangle, it really helps me. When I mark the figure, it really helps me a lot. Congruent to HFG, HFG. So I'm trying to prove these 2 triangles are congruent, okay? So I know I need 3 things, right? I need 3 pairs, whether it's side to side or angle to angle, I need 3 pairs of corresponding angles or corresponding sides, right? All right, so first step, that's the easy part, right? We're going to go L parallel to M, and we'll write EG congruent to HF, all right? And I want to mark that because that's probably going to help me, okay? So I'm going to mark my figure, EG, that's this one, is congruent to HF, okay? So if I mark my figure, okay? Now my whole goal is to come up with 3 things, right? I need 3 pairs, so I've got one. I've got 1 pair. I need 3 pairs of things, all right? I got 1. So let's check it out. So step 2 says angle EGF. EGF, that's this angle here, is congruent to angle HFG. All right. Great. How come? Oh, yeah, it's the Z. Do you see the Z? You guys see the Z? Remember the Z? What is it called? Anybody remember?
Same side interior.
Alternate. It's alternate interior angles. It's alternate because one's on one side and one's on the other. They alternate, and they're both on the inside. Does that make sense? Alternate, one's on one side, one's on the other side, and they're both on the inside of the parallel lines. Good. So now I've got 2 things. I've got a side to a side and an angle to an angle. I've got 2 pairs of things. I need 3. So the third thing is we say FG is equal to GF. Well, yeah, it's equal to itself, right? So then we're going to say that FG is equal to GF. Okay, why would I say that? What's the reasoning? Anybody remember that at all? It's the same line, right? So you're looking at your, okay, I'll give you a hint. You're looking at yourself in the mirror. You're looking at yourself in the mirror and you look at your what? Reflection, but it's not reflection, it's, you said it right, it's reflexive. Nice job, Kurt. It's reflexive. Good. Now, do I have my 3 things? Do I have 3 pairs of congruent corresponding angles or sides? Yes, I do. What are they? I've got a side, angle, side to a side, angle, side, don't I? And if I have that, let's say the triangles are congruent. So straight to triangle EGF is congruent to triangle HFG, and the reason is, what's the reason? What's the reason?
SAS.
By the side angle side. So whenever you say the 2 triangles are congruent, you're either going to say SAS or you're going to say side, side, side. Okay. All right. That's all I have. So we're going to do page 245, 2 through 12 even, 14 to 17 all, and 42 to 44 all. All right.